Background. Variable length subnet mask VLSM was designed to avoid wasting IP addresses. With VLSM, a network is subnetted and then resubnetted. This process can be repeated multiple times to create subnets of various sizes, based on the number of hosts required in each subnet. In this packet tracer physical mode, use the 192.168.33.128 prefix 25 network address to develop an address scheme for the network that is displayed in the topology diagram. Okay, this topology. Examine network requirements. Determine how many host addresses and subnets are available. How many hosts and addresses are available in a 25 prefix network? Okay, remember this is the network address 192.168.0.128 with prefix 25. This is the subnet mask. Prefix 25 is 255, 255, 255, 128 in decimal. And in binary, you have 25 ones. Okay, in binary, you will have 25 ones and 7 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, 8 plus 8, 16 plus 8, 24, 25 ones and 7 zeros. Remember, the length for the IPv4 address is 32 bits, and now you have 25 ones, 7 zeros, and now the number of bits in host portion. The number of bits in host portion is equal to 32 minus 25. Okay, 7 zeros. 7 zeros. 25 is the prefix 7. And now you can allow the number of hosts. This operation to the base for binary system, power 7 minus 2, 126 hosts. Okay, prefix 25 or subnet mask 255, 255, 255, 128 supports 126 hosts. The answer is 126 hosts. What is the total number of host addresses needed in the topology diagram? Okay, 40 hosts plus 25 hosts is 65 hosts plus 5 hosts, 70 hosts plus 4 hosts, 74 hosts plus 4 hosts, 78 hosts plus 2 hosts, 80 hosts. Okay, so the answer is 80 hosts. How many subnets are needed in the network topology? Okay, 1, 2, 3, 4, 5, 6. 6 subnets. Okay. Answer is 6 subnets. Okay, you have 3 subnets that will be implemented: BR1 LAN, BR1, BR2 link, and BR2 LAN. 3 subnets that will be implemented, but you have additional 3 subnets for the future. Determine the largest subnet. What is the subnet description? Okay, the largest subnet is this BR1 LAN with 40 hosts. How many IP addresses are required in the largest subnet? Okay, 40 hosts. What subnet mask can support that many host addresses? For example, use prefix 26. With 26 prefix, you have 32 minus 26. You have 6 bits in the host portion. Okay, 6, and with prefix 26, you have 6 bits in the host portion. So okay, and you can do this 2 power of 6. Okay, 2 is the base for binary system. Power 6 minus 2. Okay, and you will have 62 hosts. Okay, and 62 hosts will cover the required number of hosts, that is 40. Okay, remember, the required number of hosts is 40. So 62 is a good number. So the prefix is 26. But I will try with 27 prefix. Okay, for example, 32 minus 27. You have 5 bits in the host portion, and you can do the following: 2 power of 5 minus 2. You will have 30 hosts, and 30 hosts are not enough to cover 40 hosts. Okay, so this is the answer: 26 prefix in decimal 255, 255, 255, 192. Okay, so what subnet mask can support that many host addresses? Prefix 26. How many total host addresses can that subnet mask support? Okay, remember, if 26 is the answer, will support 62 hosts. 62 hosts. Can you subnet the 192.168.33.128.25 network address to support this subnet? Okay, the answer is yes, because 26 prefix is a higher number than 25. Okay, or the base prefix 25 is a lower value than 26, that is the new subnet mask. Okay, what are the network addresses that would result from this subnetting? And use the first network address for this subnet. Okay, I don't think these two questions will help you. I think this will confuse you. The only that you need is this table. This only that you need is this table to design the VLSM. Okay, and start. Use the base 192.168.30.3.128.25. 192.168.33.128.25. Okay, and go start from the highest number of hosts, BR1 LAN for the hosts. BR1 LAN for the hosts. BR2 LAN 25 hosts. BR2 LAN 25 hosts. BR2 IoT LAN 5 hosts for future. BR2 LAN IoT LAN. Okay, CCTV, HVAC. BR1, BR2 link. Okay, start from the highest number of hosts, the second highest number of hosts. Okay, 40, 25, 5, 4, 4, and 2. Final 2. At the end, 2. Okay, the link between the routers, BR1 and BR2 link. Okay, 3. Three networks will be implemented. These another 3 networks for future. Okay. Okay, and place this base network address here on binary. I will place the first 2 octets in decimal. Okay, the first 2 octets in decimal 182, 168. Okay, 33 in binary. 33 in binary is 0, 0, 1, 0, 0, 0, 0, 1. Okay. Okay, 32 plus 1. Okay, is 33. Okay, and 128. 128 is 1, 0, 0, 0, 0, 0, 0. Okay, 128. Okay, and you need for the host 62. Okay, here number of hosts 62 is a good number, and you can place the subnet mask here. Okay, and this is the network address, the new subnet 192.168.33.128. 192.168.33.128. And the prefix is 8 plus 8, 16 plus 8, 24, 25, 26. 26 prefix. allow the broadcast, and copy this, and fill the remaining spaces with ones. And this number is 192.168.33. 192.168.33 is 128 plus 63. Okay, if this is 64, this is 63. Okay, 128 plus 63 is 191. The same subnet mask 26. So allow the first IP host is easy. Is the next number of the network 192.168.33. If network is 128, this is 129. Same prefix. And last IP host is one number before the broadcast in 192.168.33. If broadcast is 191, this is 190. Prefix 26. Okay, and go to the next number is 192.168. Okay, and the next number in binary, the next number of 6 ones is 1 followed by 6 zeros. Okay, remember in binary, the next number of 6 ones is 1 followed by 6 zeros. Okay, and you need 25 hosts, so 30 is a good number. So you can set the subnet mask here. And this number is 192.168.33, 192. 128 plus 64 is 192. 192.168.33, 192. Prefix 27. Why 27? Okay, 8 plus 8, 16 plus 8, 24, 25, 26, 27. Okay. And the broadcast, copy this and fill the remaining spaces with ones. And this number is 192.168.33. 192 plus 31. Okay, 192 plus 31. If this is 32, this is 31. 182 plus 31. 182.168. 33. 223. Prefix 27. Okay, if you want to be sure, 223. Now you have 1, 1, 1, 1, 1, 1, 1. You can select this, this, using Control key and left click. Now you can see 223 down here. Okay, to be sure. Okay, the first IP host is 192.168.33, 193.27. Last IP host 192.168.33, 222. Prefix 27. Okay, next number in binary 192.168. Okay, the next number in binary, the next number of 5 ones is 1 followed by 5 zeros. Okay, and you need 5 hosts. So 6 is a very good number. Select this. Okay, and this is 192.168.33, 224. 192.168.33, 224. Prefix 25, 26, 27, 28, 29. 29. And broadcast. What is the broadcast? Copy this and fill the remaining spaces with ones. 224 plus 7. 224 plus 7. 192.168.33 is 231. Prefix 29. Okay, 224 plus 7. Okay, first IP host 192.168.33.225, and 192 last IP host is 230. Okay, and next number in binary. Okay, the next number of 3 ones in binary is 1 followed by 3 zeros. And you need 4 hosts. Okay, 6 is still a good number. So set the subnet mask. And this is okay, this number is 224 plus 8. Okay, 8. 224 plus 8. 224 plus 8 is 232. Okay, 192, 168, 083, 232. Prefix 29. Okay, the same prefix as the previous network. Okay, 25, 26, 27, 28, 29. Okay, 24, 25, 26, 27, 28, 29. Okay, the broadcast, fill the remaining spaces with ones. 182, 168, 33, 224 plus 15. Okay, 224 plus 15 or 32 plus 7, 239. The same prefix 29. Okay, first IP host 192.168.33.233, prefix 29. The last IP host 192.168.33. The previous number of 239 is 238, prefix 29. Okay, next number 192.168. Okay, the next number, network for hosts, 6 subnet mask, network address. This number is 240, 29. Okay, to be sure, this is 240. Look at this, the broadcast of the previous subnet is 239. So the next subnet will be 240. If the broadcast of the previous subnet is 231, the network address of the new subnet is 232. Okay. If broadcast of the previous subnet is 191, the network address of the new subnet is 182. Okay. Is to verify. And the broadcast, okay, and 240 plus 7, 182, 168, 33, 247. And first IP host, last IP host, okay, finally this BR1 and BR2 link, the link between routers, The next number. The next number is this. 2 hosts. The number of hosts 2 is the number, so set the subnet mask here. This is 248. Okay, you can verify. Down here, 248. Okay, 192.168, 33, 248. And the subnet mask is 30. 25, 26, 27, 28, 29, 30, 30. Okay, or if the previous broadcast address was 247, this is 248. Okay, and the broadcast, very easy. 248 plus 3, 251, prefix 30. First IP host, 249, 30. Second and last IP host, 250, prefix 30. Okay, this table is the addressing scheme, is all that you want, no more. So you can continue. Determine the second largest subnet. What is the subnet description? This is the description BR2LAN. How many IP addresses are required? 25 hosts. What subnet mask can support that many host addresses? 27 or 255, 255, 255, 224. How many total host addresses can the subnet mask support? 30. Okay. Can you subnet the remaining subnet? Yes. What are the network addresses that will result? Use the first network. Okay, these two last questions will not help. Determine the third largest subnet. What is the subnet description? BR2 IoT LAN for future. How many addresses are required? 5 hosts. What subnet mask can support that many host addresses? 29. How many total host addresses can that subnet mask support? 6. Can you subnet the remaining subnet again? Yes. What are the network addresses? Use the first network, second, third. Okay. This will confuse you, so this is all that you want. Okay, determine the fourth largest subnet. Okay, the fourth largest subnet is this 1, 2, 3, 4. But in this activity, the fourth largest subnet is this BR1, BR2 link. This is the description, BR1, BR2 link, the required number of hosts or IP addresses 2. The subnet mask is, the prefix is 30 or 255, 255, 255, 252. And 30 supports 2 hosts. Okay. Okay. Subnet description BR1, BR2 link. How many IP addresses I require? 2. Subnet mask 30. Okay. Prefix 30. How many total host addresses? 2. And these questions will not help. Design the VLSM address scheme. You will document the VLSM address scheme. Calculate the subnet information. Okay. Number of hosts, network, field host, broadcast address. Okay. This table is here. This is the answer. Complete the device interface address table. Okay. Assign the first host addresses in the subnet to the Ethernet interfaces. BR1 should be assigned the first host address in the BR1, BR2 link. Okay, and fill this table. Okay, device interface IP address subnet mask. Device interface IP address subnet mask. Device interface. Okay, BR1 gigabit 00 gigabit 001, BR2 gigabit 00 gigabit 001. On the topology, BR1 gigabit 00 is placed on BR1, BR2 link, and gigabit 000 on BR2 is placed on the subnet BR1, BR2 link. So that's why gigabit 00 on BR1 belongs to BR1, BR2 link, and gigabit 000 also belongs to BR1, BR2 link. Okay, and BR1 should be assigned the first host address in the BR1, BR2 link. Okay. So BR1, BR2 link here and here on gigabit 000 interfaces, and gigabit 001 or BR1 is BR1 LAN, okay, with 40 hosts, BR1 LAN with 40 hosts, and gigabit 001 on BR2, BR2 LAN with 25 hosts, BR2 LAN with 25 hosts, okay, and gigabit 001 on BR2. Okay, here this and BR2 LAN. Okay, for BR1, gigabit 00, use the first address in the BR1, BR2 link. Okay, here on this subnet, use the first address for BR1 249, the first IP host The subnet 30 is 255, 255, 255, 252. Okay, remember this. 30, 252, 26, 182, 27, 224. Okay, and okay, for BR2 gigabit 00, the second and last 250. Same subnet mask. Okay, on gigabit 001, BR2 LAN 40 hosts. Assign the first host address in the subnet to the Ethernet interfaces. Okay, so for BR1 gigabit 001, BR1 LAN 40 hosts, BR1 LAN 40 hosts use the first IP, and 26 is 192. Okay, on BR2 LAN 25 hosts, this use the first, and 27 is 224. 224. Okay, the table is completed. Cable and configure IPv4 network. Cable the network, the main wiring closet. Click and drag the routers and switches from the inventory shelf to the rack. Okay, and these are BR1, BR2, S1, S2. Okay, the devices on the topology. Okay, drag to the rack. Okay, for example, BR1, BR2. Okay, S1 and S2. Cable the network as shown in the topology and power on the devices as necessary. Okay, gigabit 001 on BR1 to fast Ethernet 5 on S1. Use a straight-through cable, copper straight-through. Gigabit 001 on BR1 to fast Ethernet 5 on switches 1. Another cable. Gigabit 00 on BR1, gigabit 00 on BR2. Gigabit 000 on BR1, gigabit 000 on BR2. Gigabit 001 on BR2, fast Ethernet 5 on S2. Gigabit 001 on BR2, fast Ethernet 5 on S2. Okay, and power on the router BR1, click here. You can see the green indicator. BR2, click here. Okay, for S1 and S2. Okay, by default, switches S1 and S2 are connected to the power distribution device, and this connection is enough to power on the devices, the switches. Okay, PC is already on. Okay, it's power on already. Configure basic settings on each router. Establish a console connection between the router and the PC on the table. Okay, and BR1 use a console cable to connect from RS-232 port on the PC to the router BR1 console interface. Okay, very good. Okay, very good. From the terminal window on the PC, establish a terminal session. Click on the PC, desktop, terminal. Okay. Okay. Would you like to enter initial configuration dialog? No. Enter. Assign the correct device name to each of the two routers. Okay. I will start with BR1. So enable configure terminal. Set the host name BR1. Okay. Case sensitive. Okay. Assign class as the privileged access encrypted password for both routers. Enable secret class. Okay, class is the password. Secret will encrypt the password. Okay. Cisco is the console password and enable login for routers. Okay, first access to line console 0. Okay, there is only one console, number 0. This only one port. And set the password. Okay, instruction says password Cisco. And don't forget to enable login. Okay, you need to enable the login. Okay, exit from line configuration mode and go to the global configuration mode. Cisco as the BTY password and enable login for routers. Okay, and access to line BTY. There are 16 lines from 0 to 15, 16 lines, virtual lines for telnet. Set the password Cisco and enable login. Set the password Cisco and enable login. Then exit from line configuration mode. Encrypt the plaintext passwords for routers. Service password encryption. Create a banner that will warn anyone accessing the device that unauthorized access is prohibited on both routers. Okay, create a banner message of the day. Unauthorized access is prohibited. Unauthorized access is prohibited. Enter. Okay, very good. Configure interfaces on each router. Okay, and assign an IP address and subnet mask to each interface using the table. And configure an interface description for each interface. Activate the interfaces. Okay, and BR1 configure this gigabit 000 interface gigabit 000. Okay, and IP address subnet mask 249, subnet mask 252. IP address 192.168.33.249, subnet mask 252. Okay, enter. Don't forget to add a description. Okay, you can use this description. Description BR1, BR2 link. And don't forget to activate the interface. Not shut down. Okay, now configure gigabit 01 on BR1, 129, 192, gigabit 001, 129, subnet mask 192, description, VR1 LAN for the hosts, VR1 LAN, description, no shutdown, save the configurations, and do this on privilege exec mode, copy running config to startup config, enter, okay. Okay, and configure VR2. Okay, change the console from VR2 to change the console from VR1 to VR2. Okay, drag the cable and place here. Okay, now the PC is connected to VR2. Okay, PC is connected to VR2. Click here, close the terminal, open again. Now, would you like to enter initial configuration dialog? No. Okay, and the same process but for the another router. Okay, enable configure terminal. Okay, and name, host name VR2, class privilege exec, encrypted password, enable secret class, Cisco console password, line console 0 password, Cisco login exit. Okay, Cisco BTY password, line BTY 0 to 15, Cisco login exit, encrypt plain text passwords, service password dash encryption, the banner message of the day, authorized access is prohibited when authorized access is prohibited. Enter. Interfaces, IP address subnet mask description, activate the interfaces. Gigabit 000, 250, 252, VR1, VR2 link. Okay, gigabit 000, IP address 192.168.33, 250, 252, description, VR1, VR2 link, shut down. Okay, the next interface, gigabit 001, 193, 224, VR2 LAN, 193, 224, gigabit 001, IP address 193, 224, okay, 193, 224, description, VR2 LAN, VR2 LAN, no shutdown. Okay, and don't forget save configurations, copy, run to start, enter, very good. Okay, completion 100%, but test connectivity. This is to verify from VR1 ping gigabit 00 interface on VR2. Okay, access VR1. Okay, and change the console from VR2 to VR1. Okay, now PC is connected to VR1. VR1 console, close this, open again terminal, enter and ping. Okay, remember you are on BR1 and ping gigabit 00 on BR2. Gigabit 000 on BR2 is 250. 250. 192, 192, 168, 33, 250. Success. From BR2 ping gigabit 000 interface on BR1. Okay, change the console to BR2. Okay, now PC is connected to BR2. Click here, close this, open again the terminal. Okay, you are on BR2 and ping gigabit 000 on BR1 249. 192, 168, 33, 249. Success. Troubleshoot connectivity issue is if pings were not successful. Okay, very nice. And pings to the gigabit Ethernet LAN interfaces on routers will not be successful. A routing protocol needs to be in place for other devices to be aware of those subnets. You will not be able to ping from BR1 to gigabit 001 on BR2 because you need a routing protocol. And also, you will not be able to ping from BR2 to gigabit 001 on BR1, okay, because you need a routing protocol. Can you think of a shortcut for calculating the network addresses of consecutive prefix 30 subnets? Prefix 30 network has 4 address spaces. The network address, 2 host addresses, and a broadcast address. Another technique for obtaining the next prefix 30 network address would be to take the network address of the previous prefix 30 network and add 4 to the last octet. For example, okay, if you will have the following. Okay, if you would okay, if you will have the 192.168.10.24 base network address and you require a subnet A with 2 hosts, subnet B, C, D, E, and F. Okay, B, C, D, E, and F. Okay, place this here. The first 2 octets in decimal, the next 2 octets in binary. 192.168. 1 in binary is this. 0 in binary is this. Okay, and this number is this number. And you need 2 hosts. Okay, in number of hosts, this is the 2 is the number, and set the subnet mask here. Okay, and the network is 192.168.10 prefix 30. 192.168.10 prefix 30. 8 plus 8, 16 plus 8, 24, 25, 26, 27, 28, 29, 30. Okay, the broadcast, copy this and fill the remaining spaces with 1s, and this number is 3. 192.168.13, the same prefix 30. Okay, and the next number of this is 192.168.0000001. In binary, if you have 2 1s, and the next number in binary is 1 followed by 2 zeros. Okay. you need 2 hosts. Okay, so 2 is a good number. This is the subnet mask, the same. This number is 4. Okay, 4. 192.168.1.4 prefix 30. Okay, because it's the same number of hosts are required. Okay, 4. Remember, if the previous broadcast is 3, this new subnet is 4. Okay, and the broadcast is this. Copy this and fill the remaining spaces with 1s. If this number is 7. Okay, 7. 192.168.1.7, the same prefix. And the next number of this is the following. When I do 168, the next number in binary of 3 ones is 1 followed by 3 zeros. The same prefix because it's the same number of hosts for this subnet. This number is 8. 192.168.1.8. 30. The broadcast, copy this, fill the remaining spaces with 1s. This number is 8 plus 3, that is 11, 11. Okay, and look at the pattern, 0 plus 4, 4, 4 plus 4, 8. So the next will be 8 plus 4, 12. 12 plus 4 is 16. And 16 plus 4 is 20. So this is the pattern. You can add 4 to the last octet, 0, 4, 18, 12, 16, 20. So you can determine the broadcast. Okay, if this is 16, the broadcast of the previous subnet is 15. Or use 12 plus 3, 15. 16 plus 3, 19. Okay, 20 plus 3, 23. Okay, very nice. Thank you very much.